Hello, this is Lars Minsaas, and this is assignment 2, Coprime. Again, I apologize for the audio if it is really bad, but if it is, just let me know and I can try to redo it. Let's run the code just quickly. So the first number, we'll do 3 and 5. So these are coprime, obviously, and now we'll try to do it again with numbers that are not coprime. So we'll do 9 and 18, because the smallest number divisible is not 1. And now we will exit the program, and then we will go through the questions. So how efficient is coprime AB? How did you ensure that it was not making any needless computations? Okay, so the coprime AB function uses the Euclidean algorithm to find the greatest common divisor, or GCD in this case, of two numbers, namely A and B, which are the ones that we're using. I had to do some research in finding an efficient way to find the coprime, and this algorithm was the one that seemed the most efficient. The algorithm works by repeatedly replacing the larger numbers by its remainder when divided by the smaller number until one of the numbers eventually becomes 0. The last non-zero remainder is the GCD. The function returns true if the GCD is 1, indicating that the number are coprime, and false otherwise. It doesn't involve any unnecessary calculations beyond what's needed to determine coprimality. The reason that we managed to get the code so small is because of the Euclidean algorithm, and also due to tuple swapping, where A is assigned the value of B, as here, and B is assigned the value of A percentage B, which is assigned for the remainder when A is divided by B. The algorithm is pretty efficient in using memory and avoids need for additional variables or extended lines of code. So I'm really happy I managed to find this algorithm. Yes. So, what assumptions does your code make? How easy is it for the user to crash your code? So, unfortunately, it is pretty easy for the user to crash my code, but I'll talk about that now. The code that I wrote actually makes several assumptions about its operating environment and the inputs that it is going to receive. For example, it assumes that the inputs provided A and B in coprime and those entered by the user in coprime test are integers, which is, doesn't necessarily have to happen. The user could mess me up here. This happens because the algorithm and module's operation requires integer values. Also, the interactive loop assumes that the user inputs are in correct format as requested by the user prompts. Yes. The current code and setup does not include robust error handling, unfortunately, which can lead to potential issues. For example, type errors, where if the user enters non-integer values, the program will raise a value error because the input strings are directly converted to integers without validation. This can easily make the program stop working, unfortunately. The script also assumes the user will enter yes to continue or anything else to stop, which is not optimal, but I like the shorter code, and I don't know, it looks clean to me. There's also no check for invalid entries beyond this, so any non-yes inputs is treated as command to exit. The code also does not really handle the case where either A or B is 0 or negative. But other than that, I feel like the code is pretty decent, unless you're working with someone who is trying to not have it work. But I could have put in a while loop, for example, to have another while loop to have the answer choices only be true or no, for example, or integers. But that would have made the code a lot longer and not really necessary, I thought. Yeah, thank you.